welcome everybody from Cafe. It's the BU and Harvard Climate and Health Research Coordinating Center. And today's seminar is part of Cafe's State of the Science seminar series, where we invite experts from around the globe to talk about what's known about relationships between climate exposures and health in a particular domain, and to identify remaining research gaps. So today we're going to be discussing the state of the science on drought and health, and we're fortunate to have Dr. Jesse Berman joining us today to tell us about this issue. Dr. Berman is an associate professor in the Division of Environmental Health Sciences at the University of Minnesota School of Public Health. His work investigates how extreme weather, air pollution, and climate influence population-level health. And he's led a number of groundbreaking studies on the impacts of droughts on health in the US. And so he really has a ton of expertise on this topic. Thanks, Dr. Berman, for joining us. I'm going to hand it over to you. Just one quick logistical note for folks. Feel free to put your questions in the chat as we go along, and we'll do a moderated Q&A session at the end, and we'll try to get to the questions in the chat. Thanks, Dr. Berman, and take it away.
All right, thank you, Rachel, and thanks to the Cafe for inviting me to come and speak to all of you. So today I'm going to speak about some of my work on drought and health, which I like to kind of consider as the understudied extreme weather event. And just as a little bit of background, when I started on these slides, I kind of debated with myself whether I wanted to do a talk highlighting some of our research findings on drought and health, or if particularly for this audience, it'd be more useful to speak about some of the challenges of doing drought and health research. Ultimately, after waffling back and forth, I decided on the latter, as it kind of gives a unique perspective to people who are maybe interested in drought and health but aren't actively doing this, and kind of give you a perspective as to what's involved for epidemiological research. So that said, I'm happy to speak about some of our research findings, but most of that is going to be geared towards a later date. All right, so to start off, I just want to remind everyone in the audience about the health impacts of extreme weather. I know a lot of you are already familiar with this, but it's sometimes useful to take a step back. So it's important to remember that extreme weather poses this threat to human livelihoods, our health and well-being. And the thing about extreme weather is it can either be a unique threat or it can exacerbate existing ones. And this is really important when you're thinking about pathways that environmental hazards might impact health. Furthermore, we know that the impacts of extreme weather are going to be inequitable. There are going to be some populations, outdoor workers, people with existing disease, young children, that are going to be at increased risk. And we have to carefully think about them when we're focusing on our different health outcomes. And as you'll see with drought, how we quantify our exposure. So there's definitely a growing body of literature that's evaluated the health consequences of extreme weather. This has really kind of exploded in the last, several decades. But I did want to highlight a few of these, which I know many of you are familiar with. Extreme heat is one of the most well-studied natural disasters that we're kind of looking at, not only here in the US, but globally as well. This image over here on the right was from just this past summer. We had a heat dome in late June that literally covered almost half of the United States, the entire eastern portion of it. And I know that this was really important because you had heat wave warnings running across the entire country. We know that wildfire, smoke, and air quality is another really important area of interest. This is from this winter when we had the terrible wildfire smokes in Southern California. This image right here, shows the smoke event and literally covering all of Los Angeles. We have a lot of research going on into cyclonic storms. These consist of not only tornadoes, but hurricanes as well. And this image over here is from last year in Greenfield, Iowa, showing the impacts of a tornado that went through that localized area. Flooding events is another one of major concern. This one is a picture from earlier this year down in Texas along the Guadalupe River. For those of you who remember, you had a terrible flood there, which struck many people off guard, particularly camps where you had young children and other people who are camping out. And just to highlight the urban heat island, this is another phenomenon that's really been of interest. There's a lot of great work that's being done in exposures of heat islands. And we know that in urban areas, they tend to be hotter, and that heat tends to last longer into the evening hours than in other areas. And this can definitely exacerbate health. So like I said, this isn't in any way comprehensive of all the work that's being done, but many of you are probably kind of nodding your head being like, I don't really need to know that there's been a lot of research on all of these topics. But I want to ask all of you, what about drought conditions? We don't see as much in the news about drought as a natural disaster as we saw these other images, which were all from literally this past year or this past 12 months. And this is a picture right here of someone in a dried up hayfield. And I chose this because it's in the backyard of the hosting group in Rhode Island in 2022. So why is it? Why do we not see as much information about drought? Well, I want to ask all of you, which is more compelling? This picture here of a person standing in the middle of a brown field, or some of these other images that I just showed of natural disasters and major calamities and things that are highly visible to people? Well, this is important because droughts tend to be overlooked by the public as a human health threat. And particularly, they're overlooked in non-developing and non-agrarian nations where drought conditions are these kind of events where you look and you say, yeah, it looks a little bit brown, but it doesn't look anything like any of the images on the right. And this is really important as to why drought is potentially an understudied health event. So despite this, though, drought is one of the most costly and detrimental of the natural hazards out there. These images over here kind of show the total number of people that are affected by disaster types from 1960 to present. And you can see here that while flood is the one which affects the most people, drought is definitely up there with 35% of the total population affected by natural disasters. Other things which we just showed being, so much more impactful are much smaller percentages of the overall pie. When we also look at this by total fatalities by disaster type, we see that drought now overtakes all of these other events. Now, keep in mind, most of these drought fatalities are due to famine-related events, but it still shows that drought is a major contributor to adverse health outcomes when you consider natural disasters. But despite us looking at these where drought eats up such a large portion of the pie, it's still incredibly understudied. And I always love this quote that floods kill people, but droughts destroy civilizations, to kind of show that the other things might be important, they might be more highly visible and impactful, yet it is going to be drought, which is going to be the one that actually has those long-lasting impacts. All right, so with that, let's shift gears and kind of speak a little bit about drought as an environmental hazard. So drought is really defined as this deficiency in precipitation over an extended period. So I know that's a little bit dry, no pun intended, but what drought means is that basically you're not having as much rainfall, snowfall, or anything else over a period of time. Drought can vary in duration, in its presentation, and critically, it can be exacerbated by other conditions. So when we have extreme heat, you might tend to have more drought. Or if you have more wind, you might have more drought. But conversely, if you have more drought conditions, that can drive more extreme heat. So these relationships go back and forth. It's also critical to remember that, like all weather conditions, drought is a natural feature of climate, but it can be exacerbated by climate change and human activities. Some very recent findings have shown that drought events, which are all of a sudden becoming very common and severe in Brazil and South America, is directly attributable to some of the deforestation that's taking place by there. So it's important to keep these in mind. Now, I did want to kind of highlight that drought is associated with several different human health outcomes. There has been research in this realm, some of it being led by my team, in fact. So I wanted to highlight a few of them so that people can be aware that drought has impacts on a very broad range of potential health outcomes. So here are a few studies showing that drought has been associated with worsening mental health and mental health outcomes. We know that drought conditions can cause economic burdens. They can have community hardships, including forced migrations of individuals. There's a concept called solastalgia, which is related to degraded environments. This is the idea that when you look outside and you see a degraded environment, it can actually worsen your mental health. In addition, mental health outcomes have not been equitable. There have been findings that show that it's particularly acute when it's related to drought among rural populations, which is something we'll get to in a little bit. Studies have also shown that drought has cardiorespiratory burdens. We know that drought is, related to cardiovascular and respiratory effects, but we're not quite sure of the causal pathway. But it's probably related to associations with environmental toxins. Drought conditions cause increases in dust and dust storms. It degrades overall air quality. There's been some studies that have shown that it actually changes the composition of particles and the chemistry that forms the reactions of air pollution in the atmosphere. And in addition, drought conditions can exacerbate heat, and all of these can have impacts on the cardiorespiratory system. Drought has also been linked to premature mortality risk. These associations are really critical because they kind of show that drought has an impact that can have a very severe outcome, and it impacts very broad levels of populations. So I know that premature mortality doesn't give it those particular causes, but it's really important to show the overall impact that drought events can have on large portions of the community. Finally, drought can also have strong relationships to occupational related stressors. There have been several studies that have shown that drought impacts farmers and farming communities more than others. This gives the idea that there are impacts for high vulnerability working populations when you consider drought conditions. In our study, which I highlight here below, we looked at a cohort of Midwestern farmers, and we found that when you had drought conditions during the growing season, it actually exacerbated worker-related stress 4 times higher than other stressors, such as having existing pain in parts of your body. So this is really important because it's showing that particular groups might be more vulnerable to this extreme weather event. And finally, I want to highlight some of the research that's been done showing the impacts of drought on infectious disease. It can have a wide impact on a whole different range of infectious disease outcomes. And this can be through both modifying environmental conditions that could impact both the target bug as well as vectors, and it can also impact the transfer of disease. And when we think about drought exacerbating infectious disease, it can be both exacerbation in an adverse standpoint, but can also be beneficial. There was one study that found that during drought conditions, the salinity of the Chesapeake Bay actually increased. And this caused a reduction in the presence of Vibrio in shellfish populations. So this was a kind of example of where drought conditions actually reduce the threat of people getting Vibrio infections from consuming shellfish. So even though I've just showed a whole bunch of papers to all of you, I want to highlight that despite all of this, the overall drought and health literature is quite small. It's going to be much smaller than other health extreme weather exposures, those extreme heat, those cyclonic storm types of studies, certainly the wildfire studies. And this is really perplexing, especially for an outcome that can affect so many people, can have so many different types of health effects, and can impact populations so differently. So the question persists, why is drought so sparsely represented in the extreme weather and health literature? So this is something which I've thought about a great deal, and my hypothesis is that it's because the pathway between drought and exposure and health is incredibly complex. And it's something that we've been thinking about for quite a while, and it's something which lends to the difficulty of doing these types of studies. All right, so let's think about drought as an environmental hazard and kind of get into this question as to why it's so difficult to assess. Well, number one, drought likely impacts health through a cascade of secondary events. So what do we mean by that is that Unlike, for example, wildfire smoke or temperature, where extreme temperature, we know that it has a physiological impact on populations. You can do laboratory and chamber studies where you expose people to extreme heat and see what is the physiological effect. It's far more difficult to expose someone to drought, and especially drought conditions, which can persist for long periods of time. So we think that it is through secondary events that you primarily have this pathway. Drought, as we mentioned, can increase dust. It can change chemical compositions of air pollutants. It can cause a loss of livelihood. It can disrupt economic stability. It can increase heat and actually change the structures of communities. When you have extended drought conditions, you tend to lose livelihood and people will move away. And that loses support and other resources that people relied on, and that can be extremely detrimental. So it's important to keep in mind that drought is this threat multiplier. What it does is it causes pre-existing threats to potentially become more severe, frequent, or longer in duration. And this image here kind of highlights the ways that drought can sometimes exacerbate these different threats. All right, so with that, what are the challenges that I see in terms of the drought and health research realm? So number one, I think one of the biggest challenges is that drought can affect people through multiple exposure pathways. We just highlighted a few of them before, but it's important for researchers to consider which pathway is most important for our disease of interest. Is that pathway a direct one? Is it an indirect one? Can it cause multiple comorbidities? And teasing that out can be very complex. Also, drought is a gradual onset that's often slow to develop and has unique temporal factors that we have to consider. With common environmental exposures like air pollution or temperature, it's fairly easy to measure them. We know that you can go out and actually measure the temperature outside. You can set out an air pollution monitor and you can quantify the level of particles in the air. But for drought, it's a little bit more difficult to do that. It's often difficult to determine when did a drought start? When did it end? When was a drought most severe? These things are more complex to determine. So it's really hard to define the temporality of exposures, which are so critical when we consider different health outcomes and severity. In addition, there are multiple drought indices and there's multiple definitions of drought. When you kind of look at it, you have to make a determination which drought index, which drought definition is going to be the best one to use. And should that definition vary by disease? Or perhaps should it vary by geographic region? Do we expect a drought in southwestern United States and in Arizona to be the same as the type of drought that would be experienced in New England? That's a really critical question, and you have to kind of determine, should you look at them the same way? And then finally, we have to remember that drought is this really broad population exposure. It can impact a lot of people. It hits vulnerable groups. It hits, certain occupational cohorts. So it's really something that we have to consider as to who are going to be the susceptible subgroups when you consider this broad population exposure, because those might be the ones that you target for those for interventions or perhaps targeted communications against drought and health outcomes. So with that, let's kind of discuss some of these considerations that we have to think about when doing drought and health research. I want to talk about disease outcomes. I want to talk about that idea of the selection of a drought index, and then think about how ideas related to temporality really come into play. And I've discussed a lot of these in this paper over here that we published last year, kind of outlining some of these challenges of performing drought and health research. So I'm going to highlight some of the findings in here, not all of them, but we're going to go over some of them so that you all become familiar with some of the difficulties when doing this type of work, but perhaps inform you if you plan on doing some of this on your own. Okay, so let's think about the first consideration. Does the disease affect the choice of your drought exposure? So, recapping what we mentioned before, there are multiple health outcomes that are linked to drought, and there's lots of different pathways that they can go through. So you can sometimes think of direct pathways, psychosocial stressors, perhaps nutritional or waterborne disease. Those can be most directly impacted by drought. But things such as air quality that's attributable to drought, or perhaps vector populations that are attributable to drought, or perhaps hotter temperatures that are attributable to drought, those are indirect and can also be important. So should your drought metric really focus on direct or indirect pathways, or perhaps both of them? So it's important to question, should that measure of drought vary based on what your health outcome you are targeting? Okay, so for those of you who are not aware, let's throw some complexity into this. Number one, there are four definitions of drought, and all of these definitions differ in terms of exposure, extent, and consequences. There are hydrological droughts, which are droughts that are related to water systems. So a hydrological drought would be really important for, let's say, a water manager of a community. There are agricultural droughts. So these are drought definitions that are focused on agriculture and productivity of crops, livestock, and grazing lands. There are meteorological droughts. These are droughts that are focused more in the short term and are related directly to precipitation, rainfall, snowfall, and such. And then there are socioeconomic droughts. These are how droughts impact economic activities and how they can impact them. So you have four different definitions of drought. So which one do we choose? Should your health outcome look at agricultural drought, or should it look at meteorological drought? What about hydrological one? Do we have any idea? So let's consider an infectious disease example to kind of explore some of this complexity. All right, so I'm going to focus on the first one, which is going to be a case study of infectious disease, and we're going to look at two of them. So the first one is going to be West Nile virus. So for those of you who aren't familiar with West Nile virus, and I'm not a West Nile virus expert, know that it's going to be a flu-like illness that has potentially severe neurological outcomes in a small subset of individuals who get ill. With West Nile virus, it's a vector-borne disease, and the primary vector is mosquitoes, which is over here on the right. And the primary host are going to be birds, in particular waterfowl. So when you have a mosquito that feeds on an infected bird, it can then carry the West Nile bacterium, virus inside of it. And then when it goes ahead and bites a person, like this worker over here, it can then transmit West Nile virus to that individual. So that's the basic pathway that we expect West Nile virus to impact human health. So you're probably saying, well, how does this impact, how does drought play a role in this? Well, when you have severe drought conditions, that will actually cause birds to start to congregate into smaller areas. Droughts are not only going to shrink the size of water bodies, like you see over here on the left-hand side, but in some cases, it's going to eliminate bodies of water entirely. And this is going to force birds into more and more, more crowded and dense bodies of water. So when that happens, when you have all of these birds in one place, if one or two of them are infected, you're now going to have rapid disease incubation. And when that drought ends or those birds disperse, you're going to have rapid zoonosis and spread of disease. So with that kind of laid out, what type of drought condition would you want to evaluate if you're interested in West Nile virus? Well, you'd want to look at one which forms these ideal conditions for the spread of West Nile virus, which is going to cause birds to congregate. So in my opinion, this is going to be a long-term severe type of drought, namely a hydrological one, which actually causes these surface bodies of water to change. So you want a definition that characterizes how the bodies of water change, and that's going to be really important. So now let's think of another infectious disease. Let's think of Lyme disease. I know that none of you in the Northeast are aware of Lyme disease, so I figured this would be, I'm just kidding. This would be a good example to show. But what is Lyme disease? It's a tick-borne illness, and it's really important to know that, well, let me take a step back. It's a tick-borne illness, and what we see over here is a tick in the questing position. So what happens is that ticks tend to climb up onto vegetation or shrubs or an elevated surface. They're going to reach out with their little arms over here, and when they feel something warm-blooded coming by, they will latch on and then go in for a blood feed. But for ticks to get into this questing position, they require a certain level of humidity and precipitation for them to have that physiological ability to go up there and quest. They're really highly sensitive to this. So if those types of conditions are less than ideal, ticks are not going to quest, and they're actually going to go down and burrow into the ground and leaf litter, and they're going to wait for better conditions. So how would ticks be affected by drought? Well, if drought conditions take place, it's going to prevent ticks from questing and therefore potentially spreading Lyme disease. So in this event, like I said, ticks are highly sensitive. You would probably not need a drought that is very long term, but rather something which is going to be more short term, something which causes rapid changing to reduce that humidity, reduce that precipitation, and make them unable to quest for a host. So let's consider these two vector-borne diseases, both interested in drought, but you might have two very different choices. In West Nile virus, like we said, the focus is on reduced surface water. This is probably affiliated with a long-term drought. Perhaps hydrological would be the best one for this. On the opposite side, you have Lyme disease. It's much shorter lived, very sensitive to changes in the vegetation and soil. A short-term extreme drought would probably modify these conditions. Heat is also a potential consideration. So perhaps for Lyme disease, you want to have a more short-term meteorological type of drought condition. So with this, you have different health outcomes and very different drought characteristics of concern. Therefore, if I was going to do a study of these two diseases, I might say the drought metric for West Nile virus is not the correct drought metric for Lyme disease, and vice versa. So with that, let's now think about, all right, great, we decided which type of definition of drought we want to use. So let's go ahead and select a drought index. Well, surprise, there's over 150 drought indices out there available for people to use. So if you think that a temperature or heat wave definition is challenging, just take a handle at trying it with drought. I also want to highlight that of these indices, there aren't any of them that were designed specifically for health-based research. So we really need to kind of consider which one we are interested in looking at. Furthermore, there's no consensus in the literature regarding drought indices. This is just a handful of studies that have been published recently. I kind of focus on the health outcome here and look at the drought measures over here on the right-hand side. We have different ones for all of these different studies. And how do authors choose them? Well, I'm not sure, but I know that anecdotally from personal conversations, typically the drought measure of choice tends to be a choice of convenience. It's a drought index that's available, or it's publicly accessible, or it's because the person down the hall happened to have invented this drought index and it's one you want to highlight. So there has not been good uniform decision-making in the research world as to which drought measure we want to choose. And perhaps some of that's related to some of the things we highlighted before. Okay, so how do we select a drought index? There's a number of different features we have to think about, but I like to consider three of them that are highly important for assessing health vulnerability: the severity of drought, the spatial extent of drought, and the time frame of a drought. For the sake of time, I'm only going to discuss severity and time frame right now, but it's important to know that identifying which of these are most important for your particular health outcome is going to drive your choice of the best drought indicator. So what do we mean by these different characteristics? So When we talk about drought severity, we refer to the magnitude of the water deficit compared to normal conditions. So is that magnitude of deficit minor? Is it major? Is it severe? Is it exceptional? This is kind of what we consider. But the challenge is that drought indices estimate severity differently. Some indices use continuous measures, some use categories, some use percentiles. It can be really complex to compare a severe drought with metric A with a severe drought with metric B. And this comparability makes it really difficult to compare across studies, and I haven't even thought about trying to do a meta-analysis with this. Additionally, you have to consider, is the magnitude of drought equal across an extended drought period? So what do we mean by that? So this image over here kind of highlights a drought event in Jasper County, Iowa. And I use the US Drought Monitor for this, and we can kind of see that starting in 2010, you had each of these dots represents the drought conditions during a month. You had many months of no drought, then it kind of jumped up to moderate, then it became fairly consistent as this drought event before conditions finally improved. So what's one thing to note? First off, this drought event lasted for pretty close on 3 years right now. And you also have this period where drought is worsening. You have this consistent period where it's elevated, and then you have an improving period. So when we think about, let's say, an air pollution study, we expect that the risk, if someone is exposed to, let's say, 40 micrograms per meter of PM 2.5, your risk is probably the same when you're exposed to 40 micrograms. But let's take a look at this over here. If someone is exposed to moderate drought over here in late 2011, is that moderate drought exposure the same as the moderate drought exposure here in 2014? This moderate drought in 2011, there was a long period of no drought prior to this. People tend to have resources. You have a lot of capacity built up. But that moderate drought exposure after nearly 3 years of drought conditions could have a very different health effect. So it's important to think about, is this severity equal across this long time frame of a drought? And should we kind of consider the impacts of the worsening drought period, the consistent period, and then the improving period? We might expect health to display differently when you're looking across these different exposure lenses. In addition, to add some more fun into this, is that when you're quantifying temporality across drought, drought has 2 separate time components. You have time scale and duration, and these have to be considered independently. So let me start off with duration first. That's going to be the length of a drought event. So duration is kind of more familiar to many of us in the environmental health world. If we're going to consider the duration of a let's say a wildfire smoke event, it's fairly easy to characterize. You have air monitors that show, okay, this is when the air pollution started. It started on a Monday. It was elevated on Monday, Tuesday, Wednesday, Thursday. And then on Friday, that air pollution was back to normal. It's very easy to characterize that length of that type of exposure. But for drought, it's a little more complicated. Time scale is actually the period over which your average dryness is evaluated. So remember what I said before, the definition of drought is drier than over normal conditions? Well, what is normal? This is important from a time scale perspective. Over here, I've shown 3 images of the standardized precipitation evapotranspiration index. This is for 1 month, a 1-month drought metric. So this means that it is drier over a 1-month period. Over here in the middle, this is drier conditions over a 3-month average period. And over the bottom, this is drier than normal conditions over a 12-month period. You can see that even though these are the same exact quantifications of drought, you have a very different display of kind of drought exposures. 1 month is notably choppy. Things are very up and down in terms of no drought, drought conditions, no drought, drought conditions. For 12 months, it is far more persistent and long-term. Which one is going to be best for your health effects study? Like we said, perhaps for something like a tick-borne disease, where it's very short term, that could be very important from a 1 month perspective. But if someone is looking at mental health outcomes, which take a long time to develop, perhaps the 12-month metric is going to be far more valuable. So you have to think about what is our health outcome and which one might be most useful for studying our effects. I want to just highlight over here how some of these look. So I actually took two different drought indices. This one is a standardized precipitation index. The one over here is a Palmer drought severity index. I took a 9-month variable and a 1-month variable, and I did a comparison. You would probably assume it's measuring drought. They're going to be the same. But this is at the exact same location over time, and look at how these numbers look. There's almost no relationship between drought conditions measured with one versus drought conditions measured with the other when you change that time scale. So it's really important to consider this, and it really complicates things when you're trying to compare exposures across different studies. All right, one other thing I want to touch on is this idea of quantifying the duration of drought. So remember, droughts are very long lasting. So unlike we said wildfire smoke or heat waves, which are not going to last for that long periods, droughts can last a really long time. They can last for months, they can last for years. And it's really difficult to know when exactly one starts, when one ends, and when one is most severe. Like I said, droughts aren't directly measured. There's no monitoring device that can quantify drought. So you kind of have to use these surrogates of things like precipitation, soil moisture, the level of water in a reservoir, all of these other indirect measures to kind of quantify drought. And that makes it difficult to, like I said, know when one starts and ends. And those are really important from a health perspective. In addition, when you have these long durations of drought, it can kind of throw a loop into doing a classic analysis. Things like time series and case control or case crossover types of methods don't tend to really work well with drought. In this example over here, let's say we look at this drought measure over here around like 2006 through 2008. When would a comparable exposure time for this be? Well, I guess you could look back to 2004, but we know that that's, not a very good, comparison over time. We could maybe look at the one right afterwards, but then you're kind of coming out of the drought. So it's a little bit difficult to choose a good control. And how do you evaluate something when you got this very long-term type of, exposure? So one thing that I do want to say is while this makes it challenging from an epidemiological standpoint, this long nature of exposure is beneficial from an intervention standpoint. My colleague, who I'm going to mention at the end, Dr. Jesse Bell, he does a lot of work related to interventions and communication with drought. Well, when you have a long-term exposure and when you don't really expect health effects to happen immediately when a drought takes place, we can actually put into place policies before your drought becomes really long in duration or very severe. All right, so a few final thoughts before I wrap up is I did want to mention, because I think it's super interesting, the idea of compound extreme weather events and the potentially synergistic impact of drought on other environmental hazards. So remember how drought is that threat multiplier? Well, it can exacerbate other extreme weather. It can make heat worse. It can make air pollution worse. In an ironic twist, it can make flooding worse. But is drought added on to these hazards? Is that effect going to be additive, or is it going to be more multiplicative in nature? And this is really important from a health standpoint. So I want to highlight just one study that was done by a student of mine, Dr. Austin Rao, and he did a study of US veterans with COPD and evaluated the mortality risk during heat waves, as well as heat waves plus drought conditions. So what did he find over here? First off, he found that heat waves during drought averaged about 1.5 degrees hotter, and they were about 1.5 days longer. He also found over here, you can either look at the top plot or the lower plot. It's just for single lags versus kind of a cumulative one. But the yellow dot indicates the risk during a heat wave that took place without a drought event, and the red indicates the risk of a heat wave mortality during a drought event. And what we can see here is that the risk of dying during a heat wave was substantially elevated when that heat wave took place during a drought event compared to a heat wave alone. The same thing was seen with the attributable risk. Just recently, a study was published on this exact same topic, but looking at stroke admissions. And it was really nice to see that they found very similar work in Guangzhou, China. They found that heat waves tended to be about 3.5 degrees hotter during drought conditions. And they found a markedly increased relative risk when that heat wave took place during drought compared to when it was just a heat wave during a non-drought event. So I think this was really nice to see because it confirmed some of our findings in the US. And I also think that it was really nice because this role of compound extreme weather exposures with drought is, I think, one of the most interesting areas for future research. Okay, so with that, I wanted to just kind of conclude by giving this guiding framework for drought and health research. So when I kind of think about how do you go about selecting a drought exposure, that's going to be one of the most important things that we do. You have to really consider a whole bunch of different factors, that disease of interest, that target population, how you want to characterize drought in terms of severity, temporality, the spatial extent. If you're considering this co-occurrence with other environmental hazards, and how all of these work together in terms of helping you choose that drought index to use. So basically, there's a whole lot of work to basically get to the starting point, whereas if I'm doing an air pollution study, it's really nice because I'd say, well, I'll just go to the EPA's AQS and get my air pollution measures. Well, it's not so simple with drought. But we can kind of compare this to a real life study or case study. Let's say you're looking at suicide-related deaths. Well, our target population might be agricultural or rural populations. To characterize drought, we might want to target droughts with high severity and a long duration. Those are probably going to be most associated with something as severe as a suicide-related death. Co-occurrence with extreme heat, that can be really important because that could exacerbate that crop loss or animal failure. We may want to focus on agricultural or socioeconomic definitions of drought. And then when you pull all of these together, you might say, you know what, the standardized precipitation evapotranspiration index is one which really does a good job at capturing all of these. So that's kind of how I would go ahead and use this rubric on the left to apply it to a particular health outcome to choose that drought exposure to study. So what do epidemiologists need to figure out? Well, in a perfect world, I'd love to have a single drought metric so that we avoid all of this work over here. It'd be great to have that. I don't know how soon that's going to happen, but I think that this would be really useful, and it also advance the comparability across studies and ease meta-analysis in this realm. I think we need ways to compare severity, duration, and extent across different metrics. If you can't have a single metric, well, we need better ways to compare them. We need to better identify vulnerable populations. We make assumptions, oh yeah, urban folks aren't really affected by drought, but do we know that that's really the case? I'm not sure. So we have to focus on this identification. And then critically, we have to learn what policymakers really need from us to advance early warning systems and drought mitigation plans. So with that, I do want to highlight my multiple collaborators on this work, and in particular, Dr. Jesse Bell from University of Nebraska, Lincoln. Dr. Bell and I have been collaborating on this research for a number of years right now, and our teams really work very closely together. This is a picture of him presenting on drought and health at the UN in Riyadh, Saudi Arabia. He somehow tends to present drought research in far more exciting places than I do, except for this cafe, of course. And then I want to acknowledge my funding sources from this. We've actually got a really diverse selection of funding that's helped this work. NASA and NOAA research, as well as CDC and research from the NIEHS. So with that, I am happy to go ahead and answer any questions that people might have.
Thank you, Jesse. That was a really amazing talk. I learned so much, and I loved your approach of sort of walking us through the challenges with some case examples. That was super insightful. I think we have a few questions in the chat, and I have one or two as well. Maybe selfishly, I'll ask mine first and then go to the chat. And folks, while I'm asking questions, please feel free to put more questions in the chat, and I'll try to field them and pass them along to Jesse. So my question is kind of a high level one. Do you think there's any chance that we can possibly quantify impacts of droughts via nutrition in a country like the US where our agriculture and food systems are so complex? Like, is that just a hopeless task, or do you think there might be a way that that can be done or is being done?
Yeah, that's a really good question, and it's one that I've thought about from a very high level, not into the weeds. And I think it would be challenging to answer your question. I think that so much of our food comes from other places. It's sourced from different locations. I think it would be a lot more difficult. And I'll just give an example, and I know it's not related to drought, but when there's disruptions in the food system, like I know sunflower oil, right? Sunflower oil was produced very heavily in Ukraine. And when the war started, I remember the shelves all of a sudden had no sunflower oil. And then it shifted to, I think, like Mexico, sources from Mexico. I think in the US, and this is just my guess, our food system is so diverse that if you had a drought that hit a certain area and there were other places to source food, we would be able to do that as a developed, wealthy Western nation. I think that challenge is entirely different when you have a country which is more dependent on local food sources. We see this all the time in Africa, in parts of Asia, and there you have those drought effects, which literally do impact nutrition and not only availability of food, but the quality of the food that's available. So to answer your question, I think it would be very challenging to do in the US. I think it would be a lot more feasible in other parts of the globe.
Yeah, makes perfect sense. I had another question that I see overlaps with a question that just came into the chat about you touched very briefly on the potential for mitigation strategies at the end of the talk. I was just curious, what types of mitigation strategies have been tried for floods, and do we know if any of them are actually effective?
For floods or droughts?
Oh, sorry, droughts.
Yeah, so there's actually a really strong drought communication system that is available in the US. NOAA does a great job. They have the National Drought Mitigation Center that's in Nebraska. They work really closely with NOAA, and they have webinars, and they have a lot of webinars. They have newsletters. They have other things that really highlight the risk of drought to populations. Now, most of that risk that they speak about is related more from the agricultural side and the water availability side. But we've worked really closely with them. And in particular, I want to highlight the work of Dr. Bell from Nebraska. They want to, they've created a number of sheets that have been for the CDC in terms of handouts and other ways to highlight to the general population the health impacts of drought. So I would say that the infrastructure to spread that information is there. We are working on building that piece to kind of highlight these are the health effects and these are what people need to be aware of.
Yeah, and I would assume that, like, depending on the pathway, we may have successful mitigation strategies. Like, for instance, if it's through dust, we may have, like, air filtrations, indoor air filtration or something like that that could potentially mitigate health impacts of specific pathways, although um there's probably there may be some pathways that are much more difficult to mitigate. Um let's see. So a few more questions from the chat. Um, Elaine asks, generally, are health impacts more substantial during the worsening or improving temporal section of a drought?
Yeah, so that's a really good question. I have typically found that health impacts are worse during the worsening and then that high elevated period of the drought condition. When it's improving, we tend to find that the health impacts have dropped more from that standpoint. And I'll say this, it's because and this is something which I've thought a lot about, and it's a little bit challenging, is when you can have like a big rainfall and things can get better and you can still be technically in a drought. But when you look outside, you're like, hey, things look great. It's not as apparent. So I think that's part of that disconnect where that improving portion is still like technically a drought, but from the standpoint of things that can impact health, conditions have really improved. So when we look at that exposure curve, it's definitely that first part and that peak where we tend to have the worst health impacts. And then when it's worsening, it's still elevated over baseline, but it is lower than the others that we see. And like I said, we've only done that with a couple studies, but that's kind of what we've seen at least.
Yeah, makes sense. Um, Another question from Glenn was from the research, does drought actually have an additive or multiplicative effect, or do we know that yet?
Yeah, so to answer your question, Glenn, like those papers that I showed are pretty much like it for the literature on this topic. You know, there's not too much out there. So I would say that we really don't know at this point, but at least from the few papers that exist and from what we've seen, it's definitely not like a, I think it's going to be more than additive. I don't know if it'll be quite multiplicative, but it's going to be that, yes, it's like the risk from a heat wave and the risk from a drought are not going to be just you add them together and there's your risk. It's actually going to be worse than each one of those in individually. But yeah, to be determined on that.
Thanks. Maybe another question or two. I think we have time. Oh, yeah. So Elaine also asks, how do we increase attention to drought by media, policymakers, and other researchers?
Yeah, that's it's interesting when I talk to people in like the drought mitigation centers, and like I said, they really do fantastic work. And they said talking about drought is one of the most difficult things because when you're not in a drought, no one wants to talk about it. You're like, why should we talk about drought? It's like our concern is flooding right now, or our concern is excessive rainfall. So it's really hard to get people interested in it until it actually happens. And by the time people realize they're in a drought, usually that drought is fairly severe by that point. So I think it is a challenging thing. But I will say on the positive side, I feel that the US as a whole recognizes the impacts of drought as a natural hazard. Like I said, it's not maybe always focused on health, but they recognize it impacts agriculture, it impacts rural communities, it impacts the access of food, it impacts the economic base. It has very large impacts, and I think you have a lot of support both in urban as well as rural legislators on that end. So I think that there is a great deal of, kind of interest in it, and I would say that drought's not really a, it's not a, I don't know the right word for it, but it's not an environmental hazard that people are going to point fingers at. You know, it's like droughts tend to happen, so it's kind of non, yeah, it's one that can be focused on without consequences. So, to answer your question about that, I think that there already is a good deal of attention on it. I actually think that the drought and health world is one where we've been more neglectful of it than from a policy and certainly from a meteorological and atmospheric science perspective.
That's super interesting. I was also wondering, kind of following up on that, I feel like a lot of times what makes folks take notice to these types of issues is economic costs. And have there been efforts to quantify sort of total economic costs of a drought? It seems like you could quantify some impact on farmers, but then you'd also need to take into account costs from these larger, wider health impacts. I'm just curious if that's been done already.
Yeah, the economic piece is huge. Actually, the econ literature on drought is quite large. I feel like it's only a matter of time until the econ folks jump into the drought and health world as well. So yes, I would say that economics is probably the most important or one of the most important considerations with drought. I didn't show it here and I was thinking about it, but I know that when you look at those original pie charts that I showed of people affected, total mortalities, I think that economically drought is definitely up there. It's not quite as high as hurricanes because some of those hurricanes in urban areas, are just incredibly costly. But I think in terms of like money from crop loss, it is by far the highest one.
Makes perfect sense. Okay. I think we're just about at time, and thanks for the really good questions from the audience. We also had a really nice attendance today, I think about 50 people. So thank you so much, Jesse. This is clearly a topic that a lot of folks are interested in. And yeah, getting some more comments in the chat, thanking you now. And yes, we just for folks in the audience, we will post this recording on our YouTube site. And Dr. Berman has also offered to share the slides with us. So those will be posted sometime in the next few weeks on the cafe website. Thank you so much, Jesse. This was an amazing talk. I learned a lot. And thanks everybody who joined. See you at the next State of the Science, which I believe is on green space and health coming up soon.
All right. Thanks, everyone. It was a pleasure.
Thanks.